So in the previous two chapters, we have discussed measures of central tendency and its variability, or we have studied about dispersion. However, they do not reveal the entire characteristic or the behavior of a frequency distribution. So there are two other comparable characteristics called skewness and kurtosis that help us to understand a distribution. Now, as you can see in the figure, I have drawn two figures over here. Now, these two figures represents two different distributions, and you can see one, the first figure is in a bell shape, the other one is not a bell shaped graph. So, but the peculiarity of these two figures are that when you calculate the mean and the standard deviation, that is in the figure 1, if you calculate the mean of this given data, that is here the data is 10, 30, 60, 60 and 30 and 10, the mean is 15 and the standard deviation that you get, so here you get the mean as x bar as 15 and the standard deviation sigma as 5. In the same manner, here also if we calculate the mean from the given data, that is 10, 40, 30, 60, 20 and 10, you get the mean as x bar as again 15 and the standard deviation as 5. So what we infer from here is that in both these distributions, the value of the mean and the standard deviation is the same. But it does not imply that the distributions are alike in nature. The distribution on the left-hand side is symmetrical. As you can see, it is a bell-shaped curve, and if you cut a line through the center, my line is not that straight, but if you cut a line through the center, then both the sides are identical in area wise, or they are same, and that is why we say that this is symmetrical. And the distribution on the right hand side is skewed. As you can see, it is not a symmetry that we get over there. So the measures of the skewness help us to distinguish between the different types of distribution. So that is why we take the help of another measure called the skewness. Now yeah, again, whatever I have said before, I have just written it over here. Now the definition of skewness, and this definition is put forward by Simpson and Kafka. So the definition is goes like this, that that is, measures of skewness tell us the direction and the extent of skewness. In short, it is nothing but, in symmetrical distribution, the mean, median, mode all coincide or they are identical. The more the mean moves away from the mode, the larger the asymmetry or the skewness. Now if I say a definition like this, I hope you won't understand. We will move further into detail, or we will detailedly examine what is exactly the measure of skewness is all about. Now as I have mentioned earlier in the definition about asymmetry, now let's first examine what is symmetry when it comes to a distribution. So what is symmetrical distribution? Now in a symmetrical distribution, it is said that the values of the mean, median and mode, all these three measures coincide, or all of these measures will be equal. That is, the spread of the frequencies is the same on the both sides of the center point, from the center point of the curve. Okay, so the measures from here to here is equal to the measures from this point, the center point, to the right hand side. Okay, so that is what is all about symmetrical distribution. And a symmetrical distribution, when you draw a graph regarding a symmetrical distribution, it will somewhat look like this. Okay, now asymmetrical distribution. What is a symmetrical distribution? Just the opposite of what we learned right now. A distribution which is not symmetrical is called an asymmetrical distribution. It can be either positively skewed or negatively skewed. So let's have a look at the positively skewed distribution. Graph of a positively skewed distribution might look like this, where you can see that over here we don't have a bell-shaped curve, but the tail is extended towards what, the right hand side, and you can see that here the mean is over here, the median is lesser than the mean, and then the mode. So the median lies between the mode and the arithmetic mean, and the value of the mean, the peculiarity of a positively skewed distribution is that the value of the mean is maximum and the mode will be the least, or you can write it as mean is greater than median greater than mode. And as I said before, the frequency, the tail of a positively skewed distribution is always is extended towards the right hand side. And what does that mean? The frequencies in a particular distribution is spread out over a greater range of values, or the greater range of values on the high values on the high value end of the curve. Okay, so that is all about a positively skewed distribution. So I hope now you have a very small now you might have got an idea about what a negatively skewed distribution will be. Just think about the negatively skewed distribution for a moment. Okay, now let's go on to the negatively skewed distribution. Is this what that came to your mind? Okay, so in a negatively skewed distribution, things are a bit different. Over here, the mean is the least and the mode is at its maximum, but the median lies between the mean and mode. Okay, now here mean is less than, or you can say that mean is less than median less than mode, and the values are spread out over the left hand side of the curve. Okay, just the opposite of what we have seen in the positively skewed distribution. Okay, so that was all about negatively skewed and positively skewed distribution. Now let's have a look at the test for skewness. Now in order to ascertain whether a distribution is skewed or not, the following test may be applied. If skewness is present in a particular data, the values of the mean, median and mode will not coincide, and when the data is plotted on a graph, they do not give the normal bell-shaped form. That is, when you cut along a vertical line through the center, the two halves won't be equal. The sum of the positive deviations from the median is not equal to the sum of the negative deviations. Quartiles are not equal distance from the median. Frequencies are not equally distributed at the points of equal deviation from the mode. So these are some of the points that you will see or you will witness when there exists a skewness. Okay, if the skewness is present in a distribution. Now from the definition we know that skewness is a kind of measure, and let's see, now we come to a point where how to measure the skewness. So there are certain formulas or certain measures regarding the skewness that you would have to study. So the first measure is the absolute measure, and it is denoted by SK, and the formula is x bar minus mode. So whenever after calculating x bar minus mode, you will get a value, and that value will be the measure of skewness, that is the absolute measure of skewness. Now there are a lot of measures of skewness. Now we'll study something regarding the absolute measure of skewness, and in that your formula is Sk is equal to x bar minus mode. Now what are the interpretations that you can make when you get a value for Sk? Now if the value of the mean is greater than the mode, we know that the skewness will be positive. So if the mode is greater than mean, then that is negatively skewed. So if in Sk if you get a positive value, then that means that it is a positively skewed distribution. If you get a negative value over here, then it is a negatively skewed distribution. Again, there are another measure for skewness. There are also other measures for skewness, and that is a relative measure. Now in relative measure itself, there are 4 types of measures that you will be studying. The first measure is the Pearson's coefficient of skewness. The second measure is the Bowley's coefficient of skewness. Third is the Kelly's coefficient of skewness, and fourth one is the measure of skewness based on moments. Now in this semester you will be studying Pearson's coefficient of skewness, Bowley's coefficient of skewness, and the measure of skewness based on moments. So right now we will be dealing with these 2 measures. So let's have a look at what is Pearson's coefficient of skewness. Usually Pearson's coefficient of skewness is denoted by SKP, and the formula is nothing but mean minus mode divided by the standard deviation. And it is said that there is no limit to this measure in theory, and this is a slight drawback of this particular coefficient. However, in a practical mode, we get the values, mostly the values lie between -1 and +1, but in theory there are no limit, and the theoretical values range maximum from -3 to +3. But in a practical if you do a problem, or you take real life examples, mostly the value lies between -1 and +1. So the distribution is positively skewed if the coefficient of skewness have a positive sign. That is when you calculate SKP, and if you get a positive sign, that means it's positively skewed. If you calculate SKP and if you get a negative sign, then the coefficient of skewness will have then the coefficient of skewness is a negative sign. Then it is said that the distribution is negatively skewed. Thus the formula gives us the direction and the extent of how much the distribution is skewed. Now the other measure is called as a Bowley's coefficient of skewness, where the Bowley's coefficient of skewness is clearly based on the quartiles. Okay, so a peculiarity of this measure is that in a symmetrical distribution, the first and the third quartiles are equidistant from the median, as you all know. But here what happens is that since it is skewed, if a particular distribution is positively skewed, then the top 25% of the values will tend to be farther from the median than the bottom 25%. Okay, so and SKB is how you denote Bowley's coefficient of skewness, and the formula for SKB is given as Q3 plus Q1 minus 2 median divided by Q3 minus Q1. And it must be remembered that the results obtained by these 2 measures are not to be compared with one another, especially the numerical values are not related to one another, since in a Bowley's measure, because of its computational basis, because in Bowley's measure we use quartiles for calculating the coefficient of skewness, whereas in Pearson's coefficient is all about mean, median, mean, mode, and standard deviation. And here in Bowley's measure, the limits value ranges from -1 to +1, while the Pearson's, as I said, there are no such limits. And that is the difference between the Pearson's coefficient and the Bowley's coefficient of skewness. Thank you.